Namaskar, welcome back. So, last lecture we had a brief discussion on tsunamis, and then mostly we were looking on the coastal landforms. Now, we will talk about the different tectonic environments and what sort of landforms, tectonic landforms, you will expect to see because during this different type of faulting. Okay. So, usually what we see is that we have one is the extensional tectonics. So, we have extension or extensional tectonic, then we have compression, and third is your strike slip. Now, I am not sure whether we have discussed this part or not in before, but in short I'll just explain that in extension tectonic mostly we talk about that the plates are moving away from each other. Then in compression they are either colliding, or so either they will collide or it will be there will be in subduction actually. So, this plate goes down here, whereas the two plates here will be moving away from each other. So, what you will see here in the center is the depression, or we can say also the basin formation. Now, in this case you will have the mountain building activity and the formation, or we can say the folds will be developed here. And then we have strike slip. Now, before going to the strike slip, in compressional tectonic, of course, we will discuss about that also, but we have two types of faulting with respect to your angle. Okay. So, if you are having the fault angle, usually the fault angle we say that if, so this is the fault angle you are having. So, if the fault angle, so where this block has moved up. Okay. So, we have been discussing and we have discussed at various instances that which will be the hanging wall and which will the footfall. Okay. So, this is hanging wall and this will be your footwall. Now, in the case of your extension, okay, so what you will see is that the one block is moving down with respect to another one. Okay. So, you will have sort of so this block has moved down. Okay. So, this movement is along the fault over here. So, this will be your fault. So, this block has moved down. So, this will be your hanging wall and this will be your footwall. And in reverse you have like the block has moved up. Okay. So, for example, if you have this, then this block has moved up with respect to. So, the block which moves will be your, you can say this will be your hanging wall. So, this is in case of the reverse faulting. Okay. So, if the angle of the fault is less than 45 degrees, okay, then we call that as a thrust fault. And if it is greater than that, so we can talk about that. So, if it is less than 45 degrees, then we call this as an thrust faults. And if it is greater than 45 degrees, then we call this as a reverse fault. Now, this both are in compressional tectonic environment. So, before we go to the other two part, we will discuss first the extensional tectonic environment and then we will move ahead. Now, in this lecture, we will also discuss about that how the scarps are formed, and what is the process of degradation also, because that part is important when we are talking about the paleoseismic investigations. Okay. So, basically what you see here is a typical example of your extensional tectonic, where the block has moved down. Okay. So, if you carefully see the sketch also, that shows that one block has moved down with respect to another one, and that is typical of your uh, normal faulting environment. Okay. That is in extensional tectonics. Okay, we see this. Okay. So, let us move further and then see what all things are related to the extension tectonic and the formation of the landforms. Okay. So, whenever there is sort of a displacement along any type of fault, okay, sudden displacement, then we talk that as, we say that as a co-seismic movement. Okay. Otherwise, the rest of the time what we call is the interseismic phase. Okay. So, co-seismic is a sudden displacement, either it is your normal faulting or reverse faulting, and I did not explain, but I'll just tell that part also. The lateral movement is your strike slip environment. Okay. So, sudden movement, if you have, will be termed as co-seismic displacement, and this co-seismic displacement will always be associated with earthquakes. Okay. Because earthquake process is also what we have discussed, is a sudden release of the stored energy. So, areas of extension on a larger scale, if we see around the world, then we have the sea floor spreading, that also we have already discussed, and these are termed as constructive plate boundaries along the hotspots. Then back arc basins are also the extensional, and in Andaman we have the back arc basin also. Okay. So, we have the Andaman Islands are located somewhere like this. Okay. And then we have an arc here. This is your Andaman Sumatra or Sumatra Andaman arc, or trench also we say. And then we have the back arc basin, which is sitting over here. So, this is in back arc basin. So, in this portion we will have extension going on. Then behind continental collision. Okay. Now, for this you have the best example is Himalaya, and behind that you go to Tibetan side. You have this extension which has also been seen behind the continental collision. Then along the rift, we also discussed in this case the East African Rift Valley, and here the subduction zone also you will see an extension. Okay. Where the one plate is subducting below, slight extension you will be able to see over there. Okay. So, these are the locations where on a larger scale we will see the extension going on. The extension tectonics, again if you see the distribution of that. So, this is what has been shown with the red bold line, and the arrows, blue arrows are indicating the direction of extension which is going on. Okay. So, as we discussed about this is the part of your East African Rift which we are having, and then again the extension is also there in the Red Sea Rift. Okay. So, in Himalaya, yes, this is an extension, because in the above, like if you go further north to the Himalaya, then we have the extensional regime which has been experienced, where the Tibetan side is moving towards this side actually. Then you have Baikal Rift, and Baikal Lake is also there, and then rift in Japan and all that. This is what has been shown. Of course, mid-oceanic center is also one of the area where you have the extensional tectonic going on. Okay. So, this is an example from the graben, because we also term this as grabens. Okay. So, for example, if you are having the extensional tectonic going on, and then you have like the, I'll just put here. Now, if you have the two faults which are when moving, and this portion is going down, okay, and this portion relatively it shows that it is moving up, okay, but it is not so. But in most of the cases, if there is an extension going on like this, okay, then what you are going to see is something like this, okay. So you have, so most of the geologists, they believe that there is a relative movement between along the faults, but yes, this portion remains stable, and only the movement is along downward side, okay. So this, such areas are also termed as rift valley or grabens also. And the part which has been which remain uplifted is known as Horst. So this is an example from Wyoming graben, and that can be seen in the, that is here Jackson Hole, okay, the view of Jackson Hole, Wyoming graben, which looks something like this. This is on from the Google image. Okay. So you have, and this is the whole basin over here, okay, graben. Then coming to the East African Rift Valley, this already we have discussed, so I'll just move ahead. Okay. Then Baikal Rift is there, okay, where we have the largest freshwater lake, okay. So located in Siberia, Russia, near Mongolian border. Okay. The lake is the expression of 2000-kilometer long rupture, because there is an extension which is going on. So we call this as a rupture on the earth crust that has potential of for generating destructive earthquakes. Okay, the extension on the earth crust due to the movement, or this is because of the tectonic movements between the two plates. Okay, so this lake is the biggest freshwater reservoir on planet and deepest lake in the world. So there are like very large scale features also which have been developed because of this tectonic environment. Okay, and in one of the lecture we have also discussed about the East African rift, which will result into the separation of the eastern coastline portion, and that will result into the formation of different new island. Okay. So as I was mentioning that above Himalaya, that is the northern side, you have the extension which is going on, and that is in the Tibetan side. So these are few examples on the larger scales we have in the region. Okay. And these are the regions where you will have, of course, deadly earthquakes also. Okay. So extension in Tibet, if we look at, then some researchers, they believe that this is because of the elevation which has been gained by the Himalayas, and now it is like sliding back, that is, it is like a normal faulting environment. Okay. Now paleoseismology and tectonic geomorphology in extensional environment. Okay. So paleoseismology, of course, we will talk about that, but before we need to have the understanding of tectonic landforms, because geomorphology, as we all know that this is we try to understand the surface morphology. Okay. So how, what sort of features or the landforms which are formed during the extension tectonic or normal faulting movement you will try to see. Okay. The style of deformation in normal faulting, extension along a single fault or set of faults. Okay. Then normal faulting in the upper crust, the dip of the fault will remain almost like 50 to 70 degrees. Okay. and fault are steeper near the surface and become gentler. Okay. So, it will be something like what you are having like this, okay, and this block is moving down, and it will be on surface. If you see, then this will be not in the single you line or the strike, but it will have multiple fault, as it has been shown in the photograph on your left hand side. Okay. So, extensional cracks also we usually say, but that is not related to the tectonics, that is could be related to your gravitational slide also. Okay. So, if you see the close up, then you will be able to make out easily these are the zone of. So, this whole will be your zone of deformation. Okay. So, further if you see the close up of the ground photograph, then you can make out that this block has moved down with respect to. So, this will be your hanging wall and this will be your foot wall. So, movement has occurred along this line. Okay. And the exposed section, this one is termed as your fault scarp. So, this has happened during the co-seismic slip, and that is your earthquake in normal faulting environment. Field example of this was 1954 7.2 Fairview Peak, Nevada earthquake, and the scarp height which was around greater than 3.3 meters. Okay. So, the photograph, that is the scarp height was this was in 1985, okay, which was when the photograph which was been taken. So, it remained almost intact. Okay. But now what we will do is that we will try to understand that what is the process of degradation in such type of environment. Of course, the process of degradation will depend upon the lithology. Okay. So, you can say one is your lithology also, it will depend. Okay. This will come very quickly, and what type of material or the material which is eroded from the scarp will be deposited. So, deposition at the base of the scarp. Okay. Now, in this, of course, and another important part will be the angle also, because this will be, we will be talking about the angle of repose, and the after the erosion will stop at at particular angle, it will not erode further. Okay. But in this photograph, what has been shown is, of course, it is indurated gravelly material, but at the base you see gravel deposit. Okay. So, at the base you are able to see the gravel deposit here, and that was been shown that this is, it is in last 30 years since the formation of the scarp. Okay. So, paleo earthquake evidence associated with normal faulting. Now, if you try to see a landscape using satellite data, then it shows a very clear demarcation. Okay. That is your geomorphic boundary here. Okay. And along this, what you will see, so this is like hilly areas, and this is normal, typical normal faulting if you want to see and try to identify. You will also see the sort of triangular facets. Okay. So, we call this as a triangular facet. This we will discuss when, if we have enough time to discuss about the tectonic geomorphology, but these are typical of triangular facets which you will come across in normal faulting environment. Okay. So, these are termed as triangular facets. So, triangular facets are always seen between the two drainages which are coming out here. Okay. So, if you are having recurring events, then you will see multiple triangular facets which are been preserved. Okay. So, hundreds or thousands of meter high along the this is the fault scarps. Okay. It can be quite high. Okay. Then centimeter or tens of meter in quaternary. So, if you see the older scarps, okay, because this are ongoing deformation is there since long, then you may come across hundreds of meter high scarp, and that is mountain fronts. Okay. But in quaternary, if we are talking about that, okay, in last 2 million years, then we will see a sort of an lesser height or higher scarps. It will not be too high. Okay. But depends again upon the events, how many events have occurred there. So, mainly in the soft loose sediments, because quaternary deposits mostly we say they are loose sediments. Okay. And faulting does not result into single fault scarp, it will be having multiple fault scarps. That what we have discussed in the previous one, and usually associated with secondary faulting also. So, commonly result of extension, that is secondary faulting, mostly due to secondary rupture associated with the strike slip faulting. So, in one of the lecture, we also had discussion about that you will have a combination of this and faulting environment. Okay. So, you will have, for example, you have pure normal faulting, pure reverse faulting is also there, but in strike slip you may have an oblique displacement. Okay. So, oblique in the sense that you have, for example, if we are putting normal component, then this block is moving lateral also as well as down. Okay. So, it is movement is something like this. Okay. And in case of reverse, if you say, then you can say that it is going in different direction, but along with the lateral shift as well as your the normal or reverse faulting. Okay. So, mostly normal faulting in some cases, as I would say that in like wherever there is an oblique convergence of the plates between the plate, then you will see a sort of reverse and plus the strike slip environment or normal and strike slip environment. Okay. So, this is a close up of what we were talking about, the triangular facets and very sharp front, and this sharp and prominent front you can also see in reverse faulting environment also, but you will not be able to see the triangular facets, because this triangles what we are looking here is this are itself is the fault planes actually. So, associated secondary faulting, if you have to talk about, then what we have is we have to classify or categorize this faults. Okay, main fault and then associated faulting. Okay, and that what we term as synthetic and antithetic faults. Okay. So, antithetic faults are your subsidiary normal faults that are oriented in opposite trend with respect to the main fault. So, red lines are being shown as a main fault here, and synthetic faults are those showing dip in the same direction of your fault. Okay. So, these are the two classifications we say based on the direction of dip. So, we will stop here, continue in the next lecture and talk more about the scarps and all that, normal faulting, and that will be applicable to the reverse faulting also. Okay. Thank you so much. Namaskar.